Okay, so in this video we're gonna look at generics and some objects. Okay, so when you want a property to have a differing data types, subclassing is not the answer. Okay, so what do we mean? Let's say you want to represent a question. Let's say you want to represent three types of questions. One is a fill in the blanks question and a mathematical question, and then you have a true or false question. So if you try to create a class like that, that would be like this, right? You have a fill in the blanks question and a true or false question and numeric questions. So what these classes have there, they have the same property names: question text answer difficulty, question text answer difficulty, question answer difficulty. The only thing that's different is string. Okay, the answer property has differing data types. This has string, this has boolean and integer. So what Kotlin recommends is, instead of creating multiple classes with differing data types, we should use what they call generics. So what is a generic? A generic allows you to create classes with differing data types. Okay, so generic types that allow you to have a single property that can have differing data types. Whenever you define a class, you can use a placeholder for properties that have differing data types using generics. So what is a placeholder? So they call that thing as placeholder. So let's create the that question class. So this is a generic. You can easily identify generics because they use this, what is this, greater than or less than symbol, and followed by the okay, so here we gotta put some properties in the constructor. So we're gonna copy the constructor for now, right? We're gonna copy this. So we can put the placeholder here. So this can be anything. Okay, you can put this A or B or whatever, as long as that is used here. So how do you use this generic? So whenever you instantiate the class, you can pass in the type. So let's try to instantiate that. So now if we wanted to have a fill in the blanks question, we can create it like let's call it fill in the blanks. Create an instance of this class. Now we can pass in the type to the answer. What type do we want to use? Now we want to use a string, so we can pass in string, and we can just pass in the values for it. So a question text could be, let's say, okay, like this. Okay, so that's what they are doing now here. So now they are using the generic, and they're passing in the string they're passing the data type they want whenever they instantiate the class. A more common and obvious question that you might have: we're only using one generic. What if you wanted to have two generics? What if you wanted to pass differing data types for two properties? Well, you can use comma separation for that. Now you can use that second one as like this, and now you can pass the, for example, we're using string for that as well, so we can use like this. Okay, so that's pretty much it for the generics. Let's look at the enum class. An enum class is used to create types with a limited set of possible values. Okay. In the previous section, you defined a difficulty properties with three possible values: easy, medium, and hard. So they recommend using enum class to represent these values, easy, medium, and hard, because these are finite values. I mean, these are the only values we are gonna pass to difficulty. And if we somehow since this is a string, we could pass anything to that difficulty property. So instead they recommend using an enum class. An enum class can have a limited number of options. So if you used enum class, you can only pass those values defined inside the enum class. So let's try to define enum class. The enum class can be created by, get rid of this, using the enum keyword and then class, and the enum class name and the possible options. Okay, so I'm gonna copy that and get them and paste it. Now we have a enum class. So now we can tell the class to use the difficulty enum class. Difficulty. Okay, so whenever we now pass in values for the difficulty, the only way to pass in values is by passing enum class values. So for example, here we use the medium. If we wanted to use the medium again, we need to use the enum class difficulty medium. Okay, so why do we use enum class again? If a property accepts limited values, we can define those values inside a enum class, and that property only accepts values inside the enum class, nothing else. So we cannot, for example, even we explicitly told the class that this difficulty property accepts enum class. At first it used a string, so we could literally pass anything to the difficulty properties. um, although our intention is to use the easy, medium and hard as the string values, but you can pass average, whatever really. So you can use the enum class as a data type too. So we use this is a data type and this is a generic. So some sort of type, this enum class becomes some sort of type. And data class, let's look at the data class. So many of the classes you worked with so far, such as subclasses of activity, have several methods to perform different. So data class, essentially, right, every classes has properties and methods. Some classes does not have methods. Methods are nothing but functions inside of classes. So when you have only methods, you can prefix the class with a data. You can make the class a data class. So why would you want to make a class a data class? Okay, so there are a few reasons why. When you make a class a data class, these methods, right, these 5 methods are automatically created for it. Equals as code toString component and copy. So for example, when you have a class, this is now we have a question class. Let's go here, and we have a question class, and here let me call fill in the blanks. What do we get? We get this garbage. If we made this class a data class, let's look at what happens. We get these values. So make sure whenever your classes don't have any methods, you can add you can make it a data class. Making that a data class gives you access to these methods. We don't really know what these methods are, but in the future videos we will start using them. For example, we looked at one uses of that method. When we called the instance of the class, we got this a legible string. You can tell what the object looks like. Instead, in the previous response was just some garbage. In the future videos, we will use a copy, this method. So what this method does is it copies all the properties of the you know what, it just let me show you what it does. So fill in the blanks, let's create a copy, and here answer, we're using we can pass in different answer for this. So now we can call print, and So what this copy is doing, although in this documentation they're not explaining what it's doing, what it does, but I've learned the I I know what it does. Okay, you're you've you're only modifying properties uh, using this, so all the other properties remains same, right? This question text property remained same, difficulty property remained same. When I use this copy, I can pass in properties that I wanted to change. That's pretty much it. You might want to look into what this methods does, but for now they're not explaining, and I'm not going to explain it either. Okay, so next, singleton object. So they say there are many scenarios where you want a class to have one instance. So whenever you create a class, you can have many instances of that class. We know how to instantiate a class, but how do you make a class have only one instance of it? We can make a class have only one instance of that class by making it a singleton object. How do you know you want to make a class only one class, only one instance of? What criteria do you need to make? Do you need to make the class only one instance? Honestly, I don't know. So if you wanted to make a class to have its only one instance, you can use singleton object. To make a singleton object, you just use the object keyword and the name and some values inside of the what is that, curly braces. So this object only has only one instance. So let's copy this and go back here. I don't know what this garbage is. Okay, why are we getting like that? So let's look at the class where these objects can have multiple instances. Usually you're going to create a class like this, prog. So this is a constructor of this class. So now what happens is that you can create multiple instances of this class. Okay, student 1, pass in the values. By default it's okay, student So you get it, right? We can create multiple instances of this class, but now we can't. We can only reference that only object. For example, let's print student progress total. Okay, this prints the default value 10. So how do you change the looks like we can set it. Okay, since this is a var mutable variable, we can change the variable. Anyway, so there's no way to create multiple instances of this class, because this is a singleton. It has become a singleton object. Accessing the property values of a singleton object is quite easy. You just use a dot notation followed by the property that you want to access, like they're doing right here. So what is companion object? So when you create singleton object inside of a class, it becomes a companion object. To make an object a companion of a class, you just use the companion keyword followed by object. So let's see this. Copy and so we have a class quiz. Inside of this quiz class, we have a singleton object. Whenever we create a singleton object inside of a class, we need to precede the singleton object with the companion keyword. Okay, so what does it do? Whenever we instantiate this class, this will have one instance of student progress object. Okay, so every instances of this quiz will have only one instance of this student progress. So every instances can't have multiple instances of student progress inside of that. I hope you get that. Okay, so that's pretty much it. Let's move on. Extend classes with new properties and methods. Okay, so this they're using this as an example. This is what they call a double. A double is a built-in is something Kotlin already provides, but this method is not what Kotlin implemented initially. This is what Jetpack Compose as extended. So how do you extend already defined classes? Well, let's look at them. We can add properties and methods that can be accessed with a dot syntax as if they were part of that data type. A developer who didn't work on the floating point types in Kotlin, for example, such as someone building the Compose library, might choose to add properties and methods specific to UI dimensions. Extension properties cannot be declared inside a function. They must be declared at okay, we're gonna look at what it means. So to add a extension, so let's try adding extension property. We're gonna look at how to add properties, how to extend properties and functions. So we have object. Quickly add some comments. I'm gonna get rid of some of the okay. So we have a quiz. If I wanted, the only properties we can have access is question 1, question 2, question 3. But what if we wanted to what if we wanted to make this quiz have a property called, let's say, progress text? How would we do that? First, we need to use this format. So we want to use the variable type, and then we need to create a what property we want to extend. Let's call, what are they calling? Properties text, progress text, and then the type of this variable, data type, and then a get method. And so like this. So this is what this is something I came across. So extension properties cannot be declared inside a function. Okay, what is this? This is a function, so we cannot use like this. So we gotta make it a top answered. Why am I getting like this? Student progress import property, students property. So like this, we just extended the we just added a property called progress text. Let's look at if we really added that. Quiz progress. Okay, we need to instantiate the class progress text and run. So we get some answers. So this class, we're not going inside of, we don't have, we don't have we're not put writing inside of the class. Instead, we're using the class name and the method that we want to add, type of the variable, and a get method, and we are using the answered total. So here they used student progress, but I'm not using it. Okay, they extended the singleton object, but I extended the class. So that's why I got some like this. So you can like reference the student progress object using like well, it has like this student progress. This is the one way we learn how to access. I didn't show it, but I told you. If it was let's say student progress like this, where is it? There are multiple ways to reference the values. Okay, we can either reference it by calling quiz dot progress student progress dot total, or if we use like this, we could use this. This is the same as calling student quiz dot student progress dot total. Okay, so we extended the property. How about function? A function quiz. Let's say we want to print progress bar. We want to add a method called print progress bar, and then we need to have a type. What did we do? I guess we didn't have the type. We could probably add the types for the parameters and a return type. We can add the return data types and things, but here we're not adding anything. Okay, that's pretty much it. Extending the function is much simpler. We just use the function, and then reference the class that we want to extend, and then the method name followed by the parentheses and body of the function. Pretty straightforward. We extended the class, but you can also extend the companion object as well by using the quiz dot student progress. That's what they're doing here. I'm just showing you can also extend the class. Okay, interfaces. This is a really hard concept for me to understand. I know what interfaces are, but I cannot implement this in my code, or I have no uses for this, in other words. So let's look at what it does. On the previous page, you saw how to add properties and methods to student progress object without adding code to it directly using extension properties in the extension functions. So interfaces basically defines properties and methods that classes should have. So for example, if a class, let's say our quiz class implements this progress printable interface, we're gonna look at how to create the interface real quick. What it means is that this quiz class is gonna have the properties defined inside the interfaces. For example, we have a progress text property. Although we're not we're only mentioning the variable type and the data type of the variable, we're not actually passing the value. We're gonna leave that to the class that implements that interface. Let's quickly look at how to create an interface. You just use the interface keyword followed by the name of the interface and the properties that you want the other classes to implement. This progress text properties is a immutable variable, the data type string, and this let's create this quickly. We have a quiz. Let's create this. We now have an interface to make our class extend this interface or implement this interface. We're gonna use this colon and followed by the interface. Now our class needs to implement this interface because it says it's gonna implement this interface. So this what it means is that our class has a contract. Our class will implement this interface basically. To actually implement it, we're gonna use the override. It's like our class is extending the progress printable class, so we're gonna use the override. We're gonna override the inherited thingy progress text, and this is like the how we would extend classes, properties, and functions that we looked at previously. So now whenever we call the versus quiz dot progress text, this will be called, this get method will be called. And what are we passing? Progress text. Last time we used the like this, total something, damn, of if you didn't know what this $sign and curly braces are, essentially they are evaluating the expression inside of the curly braces and putting that where the $sign is. Okay, let's also create they're also creating the quiz print progress bar. We want whatever classes that implement progress printable interface to have a print function, print progress bar function. Okay, we have one here. Let's see. We're gonna use the override in the heat. Okay, quiz. Okay, this. So whenever we call the quiz, the print progress bar, this is gonna run. This code is gonna run. Although we can just leave it like this, but when we implement the interfaces, wherever a function are some places where that interface is expected, the classes that it only gonna accept classes that implemented those interfaces. It's gonna automatically know that this class is as implement this class will have this progress text and print progress bar automatically if we implement the progress printable interface. These are really a mouthful. So now we added an interface. Let's look at this one. Use scope function to access data properties and methods. So we're gonna look at scope functions. For example, we let and apply. So what these scope functions means is that using them means you can leave out the object name whenever you want to call the methods and properties. For example, let's go here. So let's we have a class. I'm gonna call the instance of this class an object. So let's say we have a class quiz object like this. Let's say we can by using this become we can instantiate this class. Whenever we instantiate the class, I'm gonna call it an object. So now we want to access the properties. So like this, we can access the properties like this, and let's create I access to one property and question 1 property and question 2 properties. There's a way, as you can see, there's a repetition of the object name. Instead, what we can do, this scoped function, what this scoped functions really does is just some syntax bullshit where you can omit the object name. Okay, so when you call the let function on an object, you can reference the object inside of the lambda expression of let function as it. So this it variable is like quiz, like this. It's the same as calling like this. It question garbage. Let's copy paste it. Okay, so this is the same as this quiz question 1, question 2, question 3. This is like calling this quiz question 3 and things like that. We're just we're not using the object name at all. So the next scope function is called apply. I'm gonna leave it like that for now. Let's go. We have an object. Let's and apply. Inside of the lambda expression of the apply, we have access to the quiz object, but instead of it referencing the object as it, like let does, we reference it as this. This question 1 becomes like this, but we can omit this keyword and use it like this. So any methods properties can be referenced like this. So using this, you can change the chain methods on a single instance of the object. You get the reference of the same object, and you can use the method of the same instance of the object. Okay, you can see the use cases for this if you go to their documentation. Okay, like this. You can chain scoped functions. There are multiple scoped functions like this: let, run, run with, apply also. So you need to be aware of how the lambda expression, how the object is referenced inside of the lambda expression. So these properties are like always gonna be called on the object. So here we're not we can run whatever the bullshit like this, but we cannot do that. This becomes like this, print garbage, but this object does not have that method. Let's leave it like that and run. Let's see what happens. There. I guess I was wrong. So essentially you can reference the object as it, and here you can just pretty much not use the you can just pretty much use the properties and methods like this. Okay, that's pretty much it. we covered the everything. So reusable class with generics. By using generics, we made classes with different data types. By using enum class, we passed property well, whenever a property accepts limited values, we used enum class to pass in the only values inside of that enum class. A data class, by making a class a data class, you can automatically creates these 5 methods. By making class and a singleton object, or just making a class singleton object, it can have only one instance of that object. We also looked at how to make a companion object. A companion object is a singleton object inside of a class. Thus, that instance of that class will have only one instance of that object, singleton object. We also looked at how to extend existing classes with properties and functions. Rewrite extensions using interfaces. Like I said, this is really a hard concept for me to understand. So when a class implements interface, what it means is that it's gonna implement the properties and methods defined inside the interface. So this progress printable, where is it? I have it here. This progress printable adds these methods and properties. If a class extends this interface, that class must implement these 2 methods and properties. We also looked at this useScope function to access class properties and methods. So we're just accessing the methods and properties of objects without repeatedly calling the object name. Like these guys are doing here. We're calling the object name and the method, object name and method. Instead, we use the it. Okay, that's pretty much it.